Okay, so today we'll be reviewing the 2014 question 3 for AP Calc, and you can find the topic in section 2.4. So what we want to do is find the derivative of the function y equals negative 5 over t plus 3 to the cubed power. And the first thing you want to do is rewrite it so it becomes negative 5 t plus 3 to the negative third. And then you just use the product rule. So the derivative of negative 5 is 0 times t plus 3 to the negative third. And the derivative of t plus 3 to the negative third is negative 3 times t plus 3 to the negative fourth, and then times negative 5. So that's 0, and this would be the answer, but you can rewrite it as 15 over t plus 3 to the fourth power. So the next section is 3.4, and what we want to do is find the points of inflection and discuss the concavity of the graph of the function. And the function they give us is x over x squared plus 1. So the first thing we want to do is find the first derivative. The derivative of x is 1 times x squared plus 1. And then the derivative of x squared plus 1 is 2x times x. And then x squared plus 1 squared. And that simplifies to negative x squared plus 1 over x squared plus 1 squared. Next, we want to find the second derivative. And the derivative of negative x squared plus 1 is negative 2x times the bottom, which is x squared plus 1 squared. And the derivative of x squared plus 1 squared is 2 times x squared plus 1 times 2x, and then times negative x squared plus 1 all over x squared plus 1 to the fourth power. From here you can distribute. You can take out x squared plus 1 from the top and the bottom. So you're left with negative 2x, x squared plus 1, minus 2 times 2x, negative x squared plus 1 over x squared plus 1 to the third. And then that simplifies to negative 2x to the third minus 2x minus 4x plus 4x to the third over x squared plus 1 to the third. And that equals 2x to the third minus 6x over x squared plus 1 to the third. So from here, we only need the numerator, so 2x to the third minus 6x, and we set it equal to 0 so we can find the inflection points. So take out 2x, so now you know x equals 0, and x squared minus 3 equals 0 would be would become x equals plus or minus 3. And if you make a sign chart with all the values, so negative square root 3, 0, square root 3, and you plug it into the second derivative, you find out that it's negative over here, positive, negative, positive. And whenever it's negative, it's concave up, so it's concave up from negative square root 3 to 0, and square root 3 to infinity, and it's concave down from negative infinity to negative square root 3 and 0 to square root 3. Another section you guys can check out is 7.1, and the problem that we're going to be doing is number 5. So set up the definite integral that gives the area of the region, and they give us two functions that we want to set equal to each other. So 3 times x to the third minus x equals 0. And on this side, we want to factor out an x. And then we want to find the zeros, so 3x equals 0, and x squared minus 1 equals 0. So x is negative 1, 0, and 1. And then to set up the definite integral, we have to make it from 0 to, wait, you can stop it. So if you graph it in your graphing calculator, the function looks like this. And since the integral is the area, we want to do negative 1, the integral. So since you solved for the zeros, you can see that you can find the integral from negative 1 to 0, and then you put in the function. And since this area is on the bottom, you're going to want to subtract it, so minus the integral from 0 to 1. Dx. This is the answer. So for question 3 from the 2014 AP Calc, for your response, our question is the function f is defined on the closed interval negative 5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of x. And they give us the integral right here. So for a, we want to find g of 3. And so we just want to plug in 3 into the integral. So what we're really looking for is the area, and from negative 3 to 0, the area of this section would be 1/2 the base, which is 3, and then the height is 4, since it's a triangle. And from 0 to 2, it would be 1/2 2 times 4, and then minus 1/2 1 times 2 since it's below the x-axis. And that all simplifies to 6 plus 4 minus 1, which equals 9. For letter B, the question is, on what open intervals contained in -5 x4 is the graph of g both increasing and concave down? Give a reason for your answer. So we know that g of the derivative of g of x equals f of x. So we just have to look at the graph, and for g to be increasing, we know that it has to be positive. So it could be anywhere from here to here, since the values are all positive. And for it to be concave down, the line has to be decreasing. So the only intervals that are positive and decreasing would be -5 from -5x, -3, and 0x2, because the first derivative of g equals f is positive and decreasing. So for C, the function h is defined by h of x equals g of x over 5x. Find h prime of 3. So the first thing we want to do is derive h of x. So h prime of x equals the derivative of g of x times 5x minus the derivative of 5x, which is 5, times g of x all over 5x squared. And that simplifies to 5x g prime of x minus 5gx over 25x squared. And then from here we just plug in some values. So there's 5, and our x value would be 3. G prime of x would be -2, because from this graph we can just find the value. Minus 5. And g of 3 is just 9, because we figured that out in letter A. And then that's over 25 times 3 squared. 5 times 3 is 15, times -2 is 30, minus 5 times 9, which is 45, and 25 times 9. So this all simplifies to -75 over 225, and that can be simplified into a -1/3. So for this last problem, the function p is defined by p of x equals f of x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals -1. So the first thing we want to do is find the first derivative of p of x. And that would be x squared minus x. And then with the chain rule, we know that the derivative of the inside would be 2x minus 1. And our x is -1, so we just plug in -1. F of -1 times 1 is 1, minus -1 times 2 times -1, which is -2, minus 1, that simplifies to 2 times -3. And the f prime of 2 is just the slope of the graph at 2. So we just you could just count 1, 2, 3, 4. That's -4 over 1, 2, and that equals -2. So -2 times -3 is 6, and that is the slope of the line tangent to the graph of p at x equals -1.